Hello. Yes, we welcome you back to PSSB, Physical Sciences Survivability with me, Richard here. Yes, we are looking at this question today. It comes from grade 11. Yeah, and the question says that consider 800 cubic centimeter of carbon dioxide at STP being standard temperature and pressure. Okay. And the question says that calculate number of moles of the gas. How do we go about that? Yes, the best approach here is to find the relationship between the volume and number of moles. And that relationship is given by Avogadro. It says that number of moles is equal to volume over molar volume. So in this aspect, what do we know? If it is the conditions are STP, so the molar volume must be at STP. So from here, what do? We look for what we have. Okay, you're looking for number of moles. We don't know it, but we know the volume. And what's the volume? It is 800 cubic centimeter. And this is not SI unit. So we convert cubic decimeter by dividing with 1000, giving you 0.8 cubic decimeter. What else do we know? We have the molar volume. Okay. And the molar volume at STP is 22.4 cubic decimeter. So from there, we substitute. We say N, which is the number of moles we are looking for, is equal to volume, which is 0.8 over molar volume, which is 22.4, giving you so giving you this. So these are the number of moles of the gas at STP. Yeah, so we come to this one. It says that calculate the mass of the gas. Okay. So what are we looking for? We are looking for mass. Okay. But what do we know? We know N. We found number of moles already. And it is, it is 0.0357 moles. And what else do we know? We know that the compound we are dealing with is carbon dioxide. And carbon dioxide consists of one carbon, which is 12, plus oxygen, which is 16 by times 2, giving us 44. Yeah, then this information is enough to get us the mass. The relationship is known, and it is number of moles equals to mass in grams over molar mass. So if you come to substitution, what do we substitute for? You have the number of moles, which is 0.0357. Okay. Then M is what we are looking for. But we know the molar mass, which is 44. Okay, if you cross multiply here, we are going to get our M equals to 0.0357 times 44. Giving you, that is it. Giving us 1.5708 grams. Yes. Yeah, now we are looking at this one. It says that calculate the number of molecules of carbon dioxide gas. Okay. Yeah, don't mistake molecules with moles. Here we have we want the number of molecules, the CO2 molecules in this gas. Okay, what do we do here? You have to establish the relationship between number of molecules or number of particles with moles. And the relationship is clearly known. Number of moles is equal to N, which means number of entities, in this case molecules, over Avogadro. Okay, then we check with what we have. We found N already. Yes, that is it, which is 0.0357 moles. We are looking for N representing, in this case, number of molecules, and Na is also known. Na represents the Avogadro number, and in this case it is 6022 times 10 power 23. Okay, so for this, what do? We do the substitution, and what is N? 0.357. Then we are looking for number of molecules, but we know our Avogadro. So from here, what do? We cross multiply to get the answer. And N, which is number of molecules, is going to be 0.357 times 6.022 times 10 power 23, giving you, giving us this. So this is what we have for the number of molecules of carbon dioxide in this gas. Yes, so we come to this one. It says that calculate the total number of atoms present in the gas. Okay, how do we go about this? Okay, we want number of atoms, not molecules, and carbon dioxide is molecular. So what do we do in this aspect? We calculate number of molecules first. Okay, we know that number of molecules this time around, because carbon dioxide is molecular, is equal to, this is number of moles, is equal to number of molecules over Avogadro. And we know our number of moles. Yes, after quoting number of moles, then we substitute for our N, which we don't know. But we know Avogadro, which is 6022 times 10 power 23. From here, what do we do? We cross multiply, and we get our N, giving you 0.0357 times 6022 times 10 power 23. This gives us, yes, giving us this. But we must not forget that these are number of molecules. So these are number of molecules of carbon dioxide. And the question wants number of atoms. So what do we do? You have to remember, a point to note, that this is the formula for carbon dioxide. So it releases one molecule of carbon dioxide releases 1 carbon, and it is 2 oxygen. So when you combine this, what do you get? There are 3 atoms. So 1 molecule of carbon dioxide spits out 3 atoms. So what do we do in this aspect? You say 1 molecule of carbon dioxide produces 3 atoms. Okay? Yes, but we know this number of molecules. They are 21498 times 10 power 23. These are the number of molecules of carbon dioxide we have from this gas. And we are calculating the number of atoms present. So what do we do here? We cross multiply. And our x, which is the number of atoms, is going to be 3 times 2.1498 times 10 power 23, giving you, then we come to this one. It says that calculate the number of oxygen atoms present. Okay, and how do we do that? Okay, the best approach here is to first calculate the number of carbon dioxide molecules, because we are dealing with a molecular compound, and the formula is N equals to number of carbon dioxide molecules over Avogadro, where small n stands for number of moles, and this is capital N stands for number of molecules, and Na stands for Avogadro number. From here, what do? We substitute with what we have. We know number of moles of carbon dioxide. Then we substitute for N, which we don't know, but we know Avogadro, which is 6.022 times 10 power 23. When you cross multiply, you're going to get our N, which is going to be equal to 0.0357 times 10 power 6.022 times 10 power 23. Okay, in this case, you are going to get your N as, so this is what we have. And we must not forget that what we have here are molecules, carbon dioxide molecules. And the question wants number of oxygen atoms. So what do you do? You need to remember this. You need to know that carbon dioxide, having this formula, implies that it gives us 1 carbon and 2 oxygen. And the question is looking for oxygen. So what are you going to say? You come here and say that 1 molecule of carbon dioxide produces or releases 2 oxygen atoms. And we know this number of molecules. What are they? They are 2.1498 times 10 power 22 of carbon dioxide will give you X. So what do we do here? We find our X. And through cross multiplication, we are going to get our X as 2.1498 times 10 power 22 times 2, giving us that. That is that. So what we have here are oxygen atoms. So that is that. And with that, I would like to thank you for your time. The channel is PSSB with me, Richard here. We thank you for your time. We urge you to subscribe, to comment, to like, to share. Yeah. See you next time. Bye bye.